Welcome to thesiddha.com. Now in this video we will learn some of the properties of the ionic compounds. Ionic compounds we know are formed by the loss and the gain of electrons, and the oppositely charged ions are very strongly held together in an ionic compound. Ionic compounds are generally crystalline solids, and the ions, the cation and the anion in the crystalline solid, they are very strongly held together. The force of attraction is very strong, and that's why it needs a lot of energy to break those ions from the lattice points. So it's not easy to break this compound. We need a lot of energy. That is why ionic compounds have very high melting point, very high boiling point. Like in NaCl, which is an ionic compound, contains Na plus Cl negative. The ions are very tightly held together and the melting point is 801 degrees Celsius. For potassium sulfate, it is 1069 degrees Celsius. Ionic compounds are generally soluble in polar solvents like water. When we put some NaCl in water, it easily dissolves in it because the ions from an ionic compound dissociate in water. So now the ions are free. Okay? In a solid, in the crystalline solid, ions are very tightly held together. But once we put this ionic compound in water, the ions get dissociated and it makes the compound soluble. Water we know is polar. The hydrogen, being less electronegative atom, has a positive charge, small positive, delta positive. Oxygen, more electronegative atom, so delta negative. So hence water is polar. It has a positive and a negative ends, right? Ions in an ionic compound are very strongly held together when it's in the solid state, but once you put this ionic compound in water, the ions dissociate in, and the solvent molecules surround these ions. Okay, here's the cation, here's the anion. In the solid state they are strongly held together, but once you put it in water, the solvent molecules surround these ions, and the cation is surrounded by the water molecules. Anion is also surrounded by the water molecules, but cations, they interact with the negative part of the water, which is oxygen. Cation being positively charged, it will interact with the negative part of the water, right, which is oxygen. So it will interact with the oxygen. So oxygen will approach the cation, right? So water molecules will approach the cation from the oxygen end, and there will be some attraction between the solvent molecules and the cation. Similarly, anions also will be surrounded by the water molecules, but now the positive part of the water, which is hydrogen, that will interact with the negatively charged anions. And due to this attraction between the solvent molecules and the ions, some energy is released, which is called as a solvation energy, right? Solvation energy. So higher the solvation energy, more will be the solubility of an ionic compound. In polar solvents, the solvation energy is pretty high. If you have a non-polar solvent, ionic compound cannot be soluble there because ions cannot interact with the solvent molecules, with the non-polar solvent molecules, right? That's why ionic compounds are generally soluble in polar solvents like water. And here in this aqueous solution, ions, they are separated, and every ion is surrounded by a number of water molecules. So it forms like a cage around every cation or every anion, right? Solvent molecules, they form like a cage, and in the center of a cage there is a cation, there is an anion, okay, which is being surrounded by a number of water molecules. That's why ionic compounds are soluble in water. Ionic compounds in the solid state do not conduct electricity. Why? Because in the solid state we know the ions are very strongly held together and they can't move if you apply a potential difference. Okay, these ions cannot move. When you apply a potential difference here, these ions are very strongly held together, very strong force of attraction because they're closely packed in the solid state. So even if you apply a very high potential difference, it doesn't conduct electricity. So that means ionic compounds in solid state are bad conductors of electricity. They don't conduct electricity. However, if you make a solution of the same compound, right? If you dissolve the same compound in the water, and we have just discussed, we have learned that in aqueous solution, ions are free, they are separated, there is not much force of attraction between the oppositely charged ions in aqueous solution. And now if you apply a potential difference in the aqueous solution, these ions, here is the cation, here is an anion, in aqueous solution, they start moving in oppositely charged, towards the oppositely charged electrodes. Okay, so once you apply the potential difference in the aqueous solution of an ionic compound, the ions will start moving in opposite directions because ions are free. So therefore, we can get a conclusion: ionic compounds conduct electricity when they are present in aqueous solution. Similarly, ionic compounds can conduct electricity when they are present in the molten state. Okay, when you heat an ionic compound strongly and then melt it, and in the molten state, attraction between the oppositely charged ions is less. So if you apply a potential difference, these ions will start moving, and therefore it will conduct electricity. That means ionic compounds are soluble. That means ionic compounds are good conductors of electricity in aqueous solution or in the molten state, but they don't conduct electricity in the solid state. Ionic reactions are very fast. Another property, right? Another very important property of ionic compounds, that when they react, the reactions are very fast. So let's take an example, right? Suppose if I take sodium chloride, which is an ionic compound, aqueous solution of sodium chloride, if I react with the silver nitrate, AgNO3, so what I get here, I get the silver chloride, AgCl, and it forms a white PPT, white precipitation. You get a white precipitation of the silver chloride once you mix sodium chloride and silver nitrate, and you get the sodium nitrate also, NaNO3. This is an ionic reaction. Two ionic compounds react, but the reaction is very fast. As soon as you mix the two, you get the white precipitation. Immediately you get the white precipitation. So let's have a look how fast this reaction is. This is the sodium chloride, this is the silver nitrate. Once I make the solution, let me take the sodium chloride, small amount of NaCl in the distilled water, and you can easily see, this once I put some NaCl in it, it easily dissolves. So that means ionic compounds are soluble in water. Okay, you can get the solution very easily. It is soluble in water. So I got the NaCl, aqueous NaCl, and now to this aqueous NaCl solution, I'll put some silver nitrate. Okay, once I put some silver nitrate, you can see as soon as I add some silver nitrate in it, you get the white precipitation in this test tube here. This is silver nitrate solution. So once I put it here, okay, immediately you get the white PPT. Okay, so this is how fast the ionic reactions are. Okay, hope you got the concept. Thanks for watching the video. Bye for now.